13.8. Bone is actually composed of atoms having Z values ranging from 1 to 20. Number 56. Physical density, or ρ, RHO, symbolized as shown, is an important factor in determining the probability of both photoelectric and Compton effects. Density is the amount of mass per unit volume of a material. If there are more kilograms of a substance within a cubic meter, there will be more atoms with which X-rays can interact. So the probability of interaction increases as the physical density, or ρ, increases. Number 57. Bone and soft tissue have different physical densities. The density of bone is almost twice that of soft tissue. Therefore, the probability of both photoelectric and Compton effects is greater in a cubic meter of bone than in a cubic meter of soft tissue. So there are two reasons why bone attenuates more radiation than does soft tissue. There is more attenuation in bone due to its higher atomic number as well as its higher physical density. Number 58. This third important variable in determining the probability of photon interactions with matter is the energy of the photon. The probability of photoelectric effect decreases drastically when photon energy increases. The probability of Compton effect decreases only slightly when photon energy increases. Therefore, in a given type of matter, if the photon energy increases, there will be much fewer photoelectric interactions, and the interactions that occur will be mostly Compton interactions. Number 59. Here is a graph of the probability that a photoelectric interaction will take place as a photon travels through 1 centimeter of soft tissue. The method of calculating this probability is beyond the scope of this series, but the graph shown helps to illustrate an important principle of the photoelectric effect. The orange line represents the probability, and we see that the probability is high for very low energy photons. Note on the left portion of this graph how the probability increases drastically below 40 to 50 keV. This means that low-energy photons will probably undergo photoelectric interactions. But as the photon energy is increased, the probability of a photoelectric interaction falls off drastically. Number 60. This green line on this graph shows the probability that a Compton interaction will occur as a photon travels through 1 centimeter of soft tissue. Notice on the left part of this chart that the probability is not nearly as great at low energy as was the probability of a photoelectric interaction on the previous chart. Observe that the probability decreases only slightly as the photon energy increases. By comparing the previous chart with this one, we see that at higher photon energies, Compton interactions still do occur, whereas almost no photoelectric interactions occur. The information on these two charts is important because you need to know and understand the relative probabilities of both the Compton and photoelectric interactions in relationship to photon energy, as controlled by the KBP in diagnostic radiography. Number 61. In conclusion, these are the four main types of interactions of photons with matter: coherent, photoelectric effect, Compton effect, and pair production. We will use our knowledge of these interactions in the next lesson to explain the techniques used to obtain a radiographic image. Number 62. You are now ready for Review Exercise B in your student workbook. When you have completed the exercise, turn to the answer page at the end of the Review Exercise section and check your work. Then restart the tape. Stop the tape now. You should have completed Review Exercise B and checked your answers. If your score is less than 80%, you should review this material before proceeding to Section C. A score above 80% deserves congratulations. It indicates that you are mastering the material. Please rewind this tape so that it will be ready for the next person to use. Thank you.